So now let us see interference by a film with two non-parallel reflecting surfaces. This is very interesting because here fringes are formed that are of equal widths. Now you see, when it is a parallel wave film, then this ray reflects and the path difference depend on the angle of incidence because I depends on R. The path difference delta x was 2 mu t cos R, which also depends on I. So as the I changes, this will change and the fringes on the screen will be non-uniform. That means maxima, another maxima, maxima. So they won't be uniform. But for a non-parallel film, the fringes will be uniform. Let us see how. Suppose this is my film which is forming an angle alpha. Non-parallel means prismatic film is there. This alpha is small, films means these angles alpha is small or of the maximum order of 1 or 2 degree. Now again the same parallel wavefront is plane wavefront is incident normal to it by the same mechanism by using convex lens, beam splitter and all those things. So what we do is here a ray is incident near normally, it gets reflected and again here these two waves will interfere, these two waves are going to interfere. So suppose here there is a brightness, then at another locations there again these two rays are going to interfere and there will be again brightness. Again a wave will be reflected from here, some wave will pass out and again here will be another brightness. So this distance and this distance, so all the brightnesses will be equidistant from each other, means equally spaced fringes will be there, which was not the case when the film is parallel. So we will calculate what is this distance between two brightnesses and we will find that we can also calculate by calculating beta what is this angle alpha. That means this prism angle alpha can be also calculated by fringes. So let us do it mathematically. So this is my film, this angle is alpha, this is small, to show you clearly it is exaggerated and this wave is going to be incident here. So this is the first brightness, the wave reflected from here, I call it A, B. So the wave here reflected and that I am not showing. Then here again this CD. So the wave reflected from this place and this place here are under constructive interference and next another ray reflected from this upper end and this end is under constructive interference. So this path difference, this is rarer medium, denser medium, rarer medium. So you see here the path difference, this angle is alpha is small. So this will be, suppose I call this distance as x. So AB is equal to x alpha and suppose we call this as beta. So CD will be x plus beta alpha. So I drop a perpendicular here, this is E. So AB is equal to x alpha and CD. So we have ED will be equal to CD minus AB. That is this minus this, that is equal to alpha beta, where beta is the difference between two consecutive brightnesses. So we got this as how much alpha is this angle and beta. Now this is itself beta. Now at A there is a constructive interference. Ia maxima. So this film has a refractive index mu. This is one air suppose. Then we can write mu times 2 times mu into AB is equal to m lambda. So here I assume that this is denser medium. So suppose this is denser medium, then it is for constructive interference m lambda, or otherwise it will be 2m plus 1 lambda by 2, because during this reflection there is a phase shift, but here there is no phase shift. So no problem. Suppose here I assume that there is a medium called mu2 dense greater than mu. So in this case this will be m, and if 2 mu CD is equal to, then m plus 1 lambda will be. So this is the mth lambda, so it will be m plus 1 lambda. So if this is equation 1 and this is my equation number 2. So you see 2 mu CD minus AB becomes only lambda. Now suppose even if it is air, then what is happening here? Here 2m plus 1 lambda by 2 is there, and here 2m plus 1 lambda by 2 plus lambda will be there. In both the cases this difference will be lambda. So whether this is a rarer medium or denser medium, the difference of these two, that is this will be okay for both the cases. So presently this m lambda we have written, if I assume that this is here a denser medium, but rarer I have to change it by 2m plus 1 lambda by 2, and here will be plus lambda. So the difference will give only this. So we need not bother about this is denser or rarer medium. So this is CD minus AB, that is CD minus AB, that is again EB, that is 2 mu times alpha beta is equal to lambda. So finally what we got, beta is equal to lambda by 2 mu alpha. Beta is equal to lambda by 2 mu alpha. So what we see, this is the distance between two consecutive brightness which does not depend on anything else. That means which is constant, which depends only on alpha, which is same everywhere, mu which is not a variable, and lambda. That means thus we see that thus the fringes has equal widths. Fringes has equal widths. If I want to know alpha, then if we measure beta, alpha will be simply lambda by 2 mu beta. So this is a important technique to determine the alpha of a prismatic element or a film.